Okay, so in 2029, a huge asteroid named Apophis is going to scream past Earth. And when I say past, I mean closer than a lot of our own satellites. This is a true once-in-a-generation event, and you better believe scientists are scrambling to watch it up close. Today, we're going to look at two very different but equally brilliant ideas for how to do that. One mission will travel for years to escort the asteroid on its journey, while the other is going to wait right here in our backyard to ambush it. This is a fascinating clash of concepts, so let's get into it.
All right, here's the plan. First, we'll set the scene and talk about the asteroid itself. Then, we'll dive deep into the two competing mission ideas, the long-haul escort, called SATIS, and the quick-strike flyby mission, Interceptor. After that, we'll put them head-to-head to really see their pros and cons. And finally, we'll zoom out and talk about why watching this one rock is so dang important for all of us. So first up, let's meet the star of our show, this asteroid Apophis. We need to understand why its upcoming visit is making such huge waves in the scientific world. Go ahead and mark your calendars. This is the big day. Having an exact date for an event like this so far in advance is just an incredible gift. It gives us a rare chance to actually prepare for it. You know, the scale of this is what's really hard to wrap your head around. We're talking about a skyscraper-sized chunk of rock that will fly inside the orbit of our geostationary satellites, the ones that handle our global communications. It's a cosmic close shave, and it's happening right on our doorstep. Yeah, because of its size and just how close it's getting, Apophis is officially labeled a potentially hazardous asteroid, or a PHA. Now, let's be clear, it is not going to hit us in 2029, but understanding these kinds of objects is, well, it's pretty much the whole point of planetary defense. So here's the golden opportunity. As Apophis zooms by, Earth's massive gravity is going to yank and twist it. We'll get to see live if this causes things like asteroid quakes, or maybe landslides on its surface, or even changes how it spins. It's like a free planetary-scale stress test that could reveal secrets about what it's made of that we could never discover any other way. Okay, so let's look at the first strategy for studying this thing. This mission is called SATIS, and it takes the direct approach. Let's go out into deep space and meet the asteroid long before it ever gets here. SATIS is a CubeSat, one of those miniaturized kind of boxy satellites, but it has a absolutely huge job. The whole plan is to launch it on a journey that could take up to 2 years, just to catch up with Apophis and then fly right alongside it. Just look at this timeline. You can see SATIS is playing the long game here. It has to launch by mid-2027 just to have a chance of catching up. Then it'll spend months watching Apophis before the flyby. It'll have a front-row seat for the main event, and then it'll stick around to study the aftermath. This is a true marathon, not a sprint. And the payoff for that long journey? An incredibly rich set of data. By being there before, during, and after, SATIS can measure every little change to the asteroid's spin, see if the surface gets shaken up, and track exactly how its path through space gets tweaked. You get the complete story of the encounter. All right, now for the second idea, the Interceptor mission. This one has a totally different philosophy. It basically asks, why spend years chasing an asteroid through deep space when you can just wait for it to come to you? The Interceptor plan is to put 2 CubeSats into a big, looping orbit around Earth. They won't even launch until late 2028, and then they'll just wait. They'll wait for Apophis to cross their path on its way in. It's basically a cosmic ambush. Now, this encounter is going to be fast and furious. The satellites will cross paths with Apophis at a relative speed of about 8 kilometers per second. The entire window for getting precious data from just 25 kilometers away will last for about 1 minute. That's it. This mission is all about timing, precision, and getting that one perfect, fleeting shot. And here is the really clever part. To squeeze every bit of science out of that single minute, the 2 satellites will split the work. One is going to be all about getting the absolute sharpest, most detailed pictures of the surface possible. The other will observe for just a little longer to map the asteroid's overall shape and how bright its surface is. It's a divide-and-conquer strategy. So, there you have it. 2 totally different ways of tackling the same scientific goal. Let's put them side by side and really see how they stack up. This table really lays out the trade-offs, doesn't it? SATIS is this epic deep space escort that gives you months of observation time, but you have to launch super early and there's no wiggle room. Interceptor is a near-Earth flyby with only a minute of data collection, but it's way more flexible and launches much closer to the main event. One mission is about watching a process unfold over time. The other is all about capturing one perfect high-def moment.
And that's really the fundamental difference, right? Do you want the whole movie showing all the subtle changes from beginning to end? Or do you want the single highest resolution photograph of the most critical moment? The amazing thing is, they both have tremendous scientific value.
So why does any of this matter? I mean, why all the fuss over one space rock? Well, this is about way more than just Apophis. It's about understanding our solar system and, frankly, how to protect our home.
So why would we even consider doing both? Well, because it's not about being redundant. It's about being robust. For science, if you combine the movie from SATIS with the snapshot from Interceptor, you get a much more complete picture. For planetary defense, the more we know about a PHA like Apophis, the better we can predict where it's going in the long term. And for technology, both of these missions are pushing the boundaries of what we can do with small, cheaper satellites in deep space.
This quote just says it all, really. The Apophis flyby isn't just another cool thing to look at through a telescope. It's a unique natural experiment. Earth itself is doing the heavy lifting for us, putting this asteroid through its paces, and all we have to do is show up and take notes.
And that leaves us with a really fascinating thought for the future. You notice both of these ideas rely on small, relatively low-cost CubeSats. As that technology gets better and cheaper, are we looking at a future where planetary defense isn't some single, massive, expensive mission, but squadrons of tiny, agile interceptors that we can launch quickly to check out any new threat that pops up? It's something to think about.